This video, I would like to take the conceptual discussion a little one step ahead. So far in the previous videos, we have learned about the arithmetic progression and some very basic questions. In this video as well, we intend to discuss one of the questions, but before that, there are some very standard progressions that the questions keep expecting from us. For example, the first is sum of n consecutive positive integers. Now, so that is the first very important thing, which means we have to find out the sum of 1, 2, 3, and so on till n. Now, we already understand that it's an arithmetic progression with the common difference 1, so we can quickly use that property and say that the sum is equal to the number of terms divided by 2 and the first term plus the last term. And therefore we keep seeing this kind of an expression that 1 upon 2 n into n plus 1 is the sum of n consecutive positive integers. Now, having discussed this primary thing, there are two more inferences that can be drawn out of it. Right? Let me quickly discuss what is the next possible inference that we see from here. So, the next is sum of n consecutive even integers. Now, that means we have to find out 2 plus 4 plus 6 plus 8 plus and so on, because you're talking about sum of n consecutive even integers, so the nth term will be 2n. Now if you carefully see, this second is only 2 multiplied by the first progression. If I multiply the first progression entirely by 2, I get this progression. So I multiply it on the right hand side as well, and the sum becomes n into n plus 1. So that's another form of the same concept. Similarly, there is a third form that we have to quickly understand, and that is sum of n consecutive odd integers. Now, let me quickly summarize this as well. It is 1 plus 3 plus 5 plus 7 plus 9 plus and so on, and the last term will be 2n minus 1. You understand? The second term is 3, which is 2 into 2 minus 1. The third term is 6, which is 2 into 3 minus 1. So another term will be 2 into n minus 1. Now let's quickly see. If I look at only one term of the sum of n consecutive odd integers, that means only one term, the sum is 1. If I take two terms, that is 1 plus 3, the sum is 4. If I take three terms, which is 1 plus 3 plus 5, that is equal to 9. And if I take four terms, 1 plus 3 plus 5 plus 7, then the sum comes out to be 16. Looking at this now, you should be quickly understanding this thing, that it is 1 square, the second is 2 square, it is 3 square, it is 4 square. That means the sum of n consecutive integers can straight away be observed as n square. However, this can also be derived by taking the difference of the first sequence from the sequence for several equal number of terms. I mean, we'll have to equate the number of terms and then take the difference of these two series to find out this. But anyway, this observation makes it far more simpler for us to understand. There is one more thing which I don't say that it's very important from the exam point of view, but since the questions have come based on that, and knowing the property sometimes is quite helpful, therefore I'm writing here the sum of n consecutive squares, that is 1 square plus 2 square plus 3 square plus and so on till n square. It is 1 over 6 n into n plus 1 into 2n plus 1. Now this is one formula that is not very frequently used. There have been questions that have come based on this understanding, but without this formula as well we can solve those questions. So technically it is not a necessity, but I only suggest that knowing this property also is quite helpful for several questions. Now, having discussed these concepts, let me quickly move to the next question that we have to discuss here in the class, right, in this video. So here we have a question, and let us quickly understand how to answer this question now. So we have what is the 60th term in the following sequence. 60th term. To understand any such progression, if you see from 1 to 2, then increases 1, then increases 2, then increases 3, then increases 4, then 5, then 6. So this is a series which is not an arithmetic progression. We should first of all be able to define it in a form that we acknowledge, that we identify, and that we simplify. The change here can be defined this way, that first there is increase of 1, then there is increase of 2, then there is increase of 3, then there is increase of 4, and so on. That's how the terms are progressive. Now, so I start to write these terms this way. First term of the series is 1. The second term, which is 2, can we write it 1 plus 1? The third term of the series, which is 4, can I write the previous term plus 2? Now the fourth term, which is 7, is the previous term up till now plus 3. So T5, which is fifth term, that is 11, is equal to the previous term, which is 1 plus 1 plus 2 plus 3. Then you have to add 4 to it. Similarly, the sixth term, that is 16, can be written as 1 plus 1 plus 2 plus 3 plus 4 plus 5. Now you have to quickly understand the pattern here. The pattern emerging here can be seen in the second term. We are adding just 1, right? And in third term we are adding 1 to 2. In the fourth term we are adding 1 to 3. In the fifth term we are adding till 4. In the sixth term we are adding till 5, which means following this pattern we first need to understand that 60th term of the sequence will be 1, followed by 1 plus 2 plus 3 up to 59. And now you must have understood why did I discuss all those basic concepts in the beginning of this video. Now we can simplify this question, because now this again is an arithmetic progression, and the sum of arithmetic progression or consecutive numbers we already know, that is 59 over 2, 1 plus 59, that becomes 1 plus 59 by 2 times 60. And now we have to just quickly simplify this to get 1 plus 59 times 3, that is, I think it's 27 to 1770, and the answer becomes 1771. That's what our answer is. And I would rate this question at 700 difficulty level. You can see how difficult it was to decipher the meaningful progression from this question. In the next videos, we intend to discuss more fruitful questions such as this. Hope to see you in the next video. Thank you so much for watching this.